Hello, sixth grade mathematicians. We are going to go ahead and get started on solving one-step inequalities. So you need to go ahead and actually get your book open to 636. We are going to actually skip just the first page and just jump right on into the heat of the lesson. So what we're going to be doing is we're actually taking lessons 5 and 6 and we're putting them together. We're going to be solving some equations and then we're going to be graphing them on a number line. So super easy putting it all together and shabam, here we go. So I'm going to go ahead and get myself in the corner here and we are going to go ahead and get started on page 636. So make sure I'm on the right page. There we go. Okay, so taking a look at this, we are going to actually just work on addition and subtraction first, and then the next part is going to be the multiplication and division. So we're just looking at the addition and subtraction. We're working on algebra, except now all we're doing is the only thing that is going to change is this sign in the middle is not going to be an equal sign. Rather, it is going to be an inequality, meaning we're going to be using the greater than, less than, greater than or equal to, or less than or equal to signs while we solve these inequalities. And then we'll be graphing them on the number line. Again, we're going to be talking about open dot and closed dot. If you don't remember that, don't worry, we're going to review all of it. So take a look at this. It says solve x plus 7 is greater than or equal to 10. So basically, sixth graders, what you're going to do is you are just going to solve this problem like you normally would in an algebraic equation. So since we are adding 7, we have to do the inverse operation or the opposite operation of adding 7, which means we're going to subtract 7. Now, knowing what we know about algebra, whatever we do to one side of the equation, we must do to the other side of the equation. And I know that I'm hearing you say that out loud to yourself or your dog or whoever is in your room while you're filling this out. Or maybe you're doing it at school. Who knows? So we're going to drop that down because a positive 7 and a negative 7 cancel each other out. So adding 7 and then taking away 7 makes 0. So that cancels out. And so I'm left with just x. And I'm going to bring down my greater than or equal to, and then I'm going to solve. So we're going to do 10 minus 7, which is 3. Now, when we do this, I take a look and I'm like, okay, so my answer on my number line is going to directly reflect the problem that I just solved. So my x has to be greater than or equal to 3. Well, that means that I'm going to circle that 3. Since it is equal to, that dot needs to be filled in because 3 is a possible solution. And then we're going to do anything that is bigger on that side. So you're like, wow, this is just like algebra. It sure is. So this is our solve. What do you think I'm going to make you do? That's right. You're going to have to do the check. Let's do the check over here. And you're like, okay, Mrs. Horner, how do I check? We're going to rewrite the algebraic inequality here. Okay, that looks like this. Now I'm going to pick any number that is on that number line that is shaded in. Okay, so we said it should go this way. So I'm going to pick any number. Okay, well, I don't know. Let's just pick 7. Okay, so I'm going to pick 7. I'm going to replace that 7. Actually, let's not pick 7 because I have 7 already in mind. Let's pick 8. Okay, so I'm going to replace my variable with 8 to check to make sure that any of those answers is right. So 8 plus 7 is greater than or equal to 10. So now I solve 8 plus 7 is 15. Is 15 greater than or equal to 10? Check. This means that all of these that are going this way, okay, all of the ones that I have shown my line, that those are all possible solutions. Is it infinity? Absolutely. That's why there's the arrow at the end. Okay. Could 3 be a choice? Absolutely. Okay. All right. Let's jump down and let's practice a couple. So first things first, I want you to go ahead, go like this. Let's do a solve and check. And we're going to go ahead and write n plus 2 is less than or equal to 5. And then we're going to rewrite it again in our check. N plus 2 is less than or equal to 5. Okay, so first thing we're going to do is we're going to solve this. If I'm adding 2, the inverse operation of adding 2 is subtracting 2. Whatever I do to one side of the equation, I must do to the other side of the equation, because I want to get this variable, this n, by itself. Okay, I want to isolate that variable. A positive and a negative 2 make 0, so we're going to cancel that out. And n is less than or equal to, and now I'm going to do 5 minus 2, which luckily I don't need a calculator for that, is 3. Okay, so now I get n is less than or equal to 3. So I'm going to circle 3 because that's going to reflect what I'm graphing. Okay, not this. This has nothing to do with it. I've got to get my answer. So n is less than, which means my arrow is going to go to the left. Now let's talk about, is it an open dot or is it a closed dot? It is less than or equal to. Because it is or equal to, I have to fill that in. Okay, 3 is an answer. So how do I check it? I look at my line right here. This is my line. I'm going to pick a number that is on that line as a possible solution. So let's pick 1. Do you have to pick 1? No. Guess what? Everybody's check is going to be different. So I'm going to put 1, I'm replacing my variable with 1, plus 2 is less than or equal to 5. So 1 plus 2 is 3. Is 3 less than or equal to 5? Well, yeah, 3 is less than 5. Check done. Okay? All right. Let's take a look at, if I'm going too fast, you're stopping and pausing at any point. Okay? Just don't mute me. Okay? All right, the next one. I'm going to kind of scroll down here. I'm going to do my check, my solve and check down here. I'm going to move this up. Solve, check. We're going to do y minus 3 is greater than 9. Y minus 3 is greater than 9. Okay, I'm going to isolate the variable, get that y by itself. Since I'm subtracting 3, the inverse operation of subtracting 3, or the opposite operation, is adding 3. Whatever I do to one side of the equation, I must do to the other side of the equation. I know, it's a broken record. Doesn't matter. Positive 3 and negative 3 cancel out. I'm now left with just my variable, which is y. Y is greater than, and I'm going to add my 9 plus 3, which is 12. So now I've got y is greater than 12. So I'm going to circle my 12. Okay. So I might even kind of arrow that over, and I'm going to do the same thing here. That way you know what you have to graph. Okay, so y is greater than 12. Open dot, closed dot. Open dot, because 12 is not included as a solution. So open dot, y is greater than, so my numbers have to be bigger than 12, which means it's going to go that way. Okay, let's check it. Let's pick an answer that is on here. I don't know, let's pick 15. Okay, so I'm going to replace my variable with 15. Minus 3 is greater than 9. 15 minus 3 is 12. Is 12 greater than 9? Does that make sense? Oh my goodness, look at my pretty family. Well, let's see, right there. Huh. Okay, yes, check done. Okay, all right. So 12 is greater than 9, so therefore we know we have done that correctly. Is anything going to change when we go to multiplication and division? Nope, absolutely not. So we're going to jump right down here, and we're just going to do some practicing with multiplication and division. So let's take a look at C. We're going to write C over here. So we're going to do solve, and we're going to do check. And it looks like it is 10x is less than 80. So we're going to write 10x is less than, 80. There we go. Okay, so we know when we have a number and a letter together, or a number and a variable together, we know that we're multiplying. So the inverse operation of multiplying, to get that variable by itself, or to isolate that variable, we're going to divide. So we're going to divide, and we show division with the bar, okay, just like a fraction. And we're going to go ahead and divide both sides by 10, okay? So 10 divided by 10 leaves me with 1x, okay? So that leaves me with my x. That makes sense, doesn't it? Okay, is less than, and I'm going to take 80 divided by 10, which is 8, and I'm left with x is less than 8. So I'm going to go ahead and circle 8. Now, open dot, close dot, open dot, because 8 is not included in the solution. So x is less than, so if we're talking less than, my arrow must go this way. Shabam. Okay? Now, let's pick a number to check it with. So remember that that becomes my number line. Let's just do 5. Okay? So to check it, we're going to do 10 times 5, remember I'm going to put it in parentheses, is less than or equal to, or I'm sorry, not equal to, just less than 80. So 10 times 5 is 50. Is 50 less than 80? Check. We've done it correctly. Okay, very good. Let's take a look at this next one. Now this is where the check gets not necessarily tricky, but you want to think of solve and check. You're going to want to think of a multiple. So we have x divided by 6 is greater than or equal to 7. X divided by 6 is greater than or equal to 7. So here we go. Since I'm dividing both sides by 6, the inverse operation would be multiplying by 6. So I'm going to multiply both sides by 6. Okay? When I'm dividing by 6 and multiplying by 6, I'm left with my variable of x is greater than or equal to, and then 7 times 6 is 42. Okay, so 42, is it included in the solution? Yes, it is a closed dot because it's got that equal sign underneath, and my x is going to be greater than 42. So now, when I think about this, I'm looking and I'm like, okay, well 42 is a solution, so I probably should pick 42. I want to pick a multiple of 6 so I can easily mentally divide by. So I would pick a multiple of 6. 42, I could pick 48, right? So forth and so on. Okay, any number that is greater than or equal to 42. So I'm just going to go ahead and pick 42 because it's showing on this number line. But just know that I can pick 48. I can pick 54. It doesn't matter. Okay, you can pick other numbers that even are on this list because that's what that arrow implies. It's further on. Okay, so I'm going to take 42 and I'm going to go over 6 is less than or greater than or equal to 7. So 42 divided by 6 is 7, and I get 7 is greater than or equal to 7. Is that true? Yes, it is. Okay, so here's what's going to happen. Because this is a culminating review over lesson 5 and lesson 6, if you're feeling comfortable, good, you're done. You don't need any more practice, then that's fine. If you want more practice, there's going to be a second video, and it is just going to include some problems that are on the next pages. It's going to have a little bit of fractions, okay, in case you're maybe just wanting some more practice. But again, if you're comfortable and you're feeling good, then you are done. That's all you need to do. If not, go ahead and stick around and watch the other video just for some more practice.